Love is in the air, everywhere I look around. Love is in the air, every sight and every sound. I don't know if I'm being foolish, don't know if I'm being wise, but it's something that I must believe in, and it's there when I look in your eyes. This is the beginning of one of the most famous songs ever. It came out in 1978 by an Australian singer called John Paul Young. It's of course a declaration of love with simple words and a simple music. It flows very well, it's very fluid. Okay, but if love sometimes is in the air, today we could say that love is also in the airless, and more specifically in the airless spray system usually used for grid suspensions application. The subject of today's podcast, in fact, is all about the problems that may arise during this stage of the ceramic production process, with a focus on one of the most frequent and annoying, the nozzles obstruction. I am Davide Trentini, and this is Apparently Invisible, Chemistry in Ceramics. Let's start, as usual, from the basics by providing a very short definition of a grid suspension. A grid suspension is a mixture of different ingredients, but for sure the big three are the grid powder, obviously, water and binders. The suspension, before being applied by means of spray system technology, usually rests inside the tanks for a period that can range depending on the situation and where it's constantly under steering, so to avoid possible sedimentation phenomena. Even the rate of each component can change according to the production parameters, but in any case, the formula must be developed in order to reach a stable suspension. As we said, the suspension after being prepared rests inside the tank that are, we could say, connected to the spray cabin. At this stage, water and leavening agent, or more generally functionalized agent, are also added to get the right parameters in terms of density and viscosity, and therefore to develop a proper application. It is not unnecessary to recall at this point that even these serological values cannot be standard, since the production parameters of each ceramic company are different from each other. And by implication, this means that all grid suspensions must be previously studied inside the lab to avoid critical issues during the production. And now a very few words about the spray cabin and airless application system. And we do it as usual, trying to simplify without making it trivial, hopefully of course. So, I'm sure that most of you already and perfectly know what are we talking about, but the question is, what are the main elements or tools of a spray cabin for engobes, glaze or grid applications? Well, you just have to imagine that tiles move along the production line from the pressing stage to the kiln on the conveyor belts. And in more than one just phase, they enter inside the cabins, where at top of them there are one or more sprayers that are all provided with a nozzle through which the suspension is discharged on the tile. Okay, let's go further by adding that the proper setup of the spray cabin is the precondition of the grid correct application. And among all aspects that must be considered, we just list here the most important. First, the number and the kind of nozzles of the spray cabin. Second, the distance between one nozzle and the other. Third, the distance between the nozzles and the ceramic tile. Fourth, the pressure with which the grid suspension is discharged on the tile, and finally fifth, the speed of the conveyor belt. Speaking about the nozzles that discharge the grid suspension, and that by the way is our subject, we can say that they are provided with a hole that can change both in terms of diameter and opening angle. The hole dimension can usually range from 0.05 to 0.17 cm, while the opening angle can swing from 65 to 130 degrees. After this introduction, now we enter the heart of the problem, because during the grid application some critical issues of course may occur, and one of the most popular, and we can surely say frequent, is the obstructions of the nozzle. And when this happens, since they must be removed, cleaned and reassembled, the impact of the production is very strong because it often stops the process along the glazing line with all the consequences. But what are the reasons and the origin of the obstruction? As usual, these are many, so we need to choose the most significant. Even before you analyze the suspension parameters, the first recommended action is to check the machine setup, modifying or, when necessary, changing the kind of nozzles as well as the pressure with which the suspension is applied. This first action, in several cases, could solve the problem without any intervention on the suspension in terms of grit or chemicals. Even if the grit producers, of course, are very careful about the quality of the raw material, sometimes grit batches may contain non-standard grain size. And these grains, that are of course too big, since they exceed the proper and requested dimension, they do not pass through the holes of the nozzles, leading obviously to a blockage of the nozzles and so to a production stop. This scenario, to be honest, is very extreme and uncommon and is quite difficult to find a remedy during the application. In the best cases, it's possible to use a sifter inside the tank to retain and remove the biggest particles, and more frequently, the only way forward is to, and the most effective, is to replace the grit with a proper batch. Sometimes, and this is the third scenario, the grit in solution can be not perfectly and homogeneously dispersed in water. What does that mean? It means that the grit behaves independently and separately from the fluid in which it is contained, that, as already know, is mainly composed by water and chemicals. This independent behavior of the grit stands for a low wettability of the grit, and this makes the suspension a heterogeneous system, leading to phenomena that are very similar to those of the sand behavior inside a glass of water. During application, it is possible to find aggregation phenomena right at the nozzles. In these cases, it is recommended to use a wetting agent that can be previously added during the preparation of the suspension or directly along the glazing line when the production is already in progress. But how does a wetting agent act? Let's try to explain it in simple words. Wetting agents are partially or slightly water-soluble medium composed of organic molecules able to decrease the water surface tension that is very, very high, as we know. This kind of decrease helps the penetration of the water between the suspended solid particles that are holding air between one and another. The water, thanks to this process, hydrates every single particles, leading to their homogeneous dispersion within the fluid, and therefore producing a de-agglomeration of the solid elements. Once they have been wet, the particle of the grit can freely move inside the suspension and slip on each other, avoiding the clogging phenomena at the nozzles. It is now important to point out that both the dosage and the kind of wetting agent always change according to the solution, the features of the water, the kind of suspended grit, and of course the application parameters. Sometimes, however, the wetting agent, even if it has been properly developed, it is not able to reach the target. In all these cases, it's important to carefully study the suspension in the labs to identify the right mediums that can match the grit in use. And now, before we say goodbye, let's see shortly the last scenario. Sometimes, even if the system is homogeneous and provided with a good wettability, low values of viscosity together with the lack of flow limit, that is, in this specific case we could commonly define as the ability to suspend the grit, can lead to rapid sedimentation phenomena of the grit that in turn can lead to different kind of problem during the application. In these cases, two different steps are required. First, take immediately action along the production line by using proper rheological modifiers able to restore the proper values in terms of viscosity, density and flow limit, and so making the system more cohesive. Second, once the problem has been solved along the glazing line, it is a good practice to proceed inside the lab with a new study of the sample of the customer's suspension by analyzing and rectifying all the parameters. And even this episode ends here. And so I thank you very much for traveling with us. As I already said in one of the previous episodes, I hope I gave you some food for thought. And if you want to deepen the subject, of course, you can write us, finding all contacts on our website, which is ceramco.et, ceramco.at. I finally remind you that all the podcasts are available not only on the main platform, such as Spotify, Apple or Google Podcasts, but also on our app that you can download for free on Apple Store or Google Play. You can find it by typing ZNS Ceramco, again ceramco.at, or apparently invisible. Don't forget that love is in the airless, only when everything is working properly. See you in 2 weeks.